Right. So if you look here, so these are some of the things that you need to pay attention to, right? If you have an event, you'll see it now. So if you have an event, why is this now? Right, nice. If you have an event and you recognize that it could be repeated properly, right? If you have an event and it could be repeated a finite number of times, then that particular rule gives you an idea. There's a chance it could be binomial. Next, if it has only two outcomes. So for example, let's say you write an exam, right? And you write the exam a finite number 200 times, right? Then when you write the exam, you only have two outcomes, right? Either you pass it, you're successful in it, or you fail it. That's okay? Hopefully there's no in between. Either you're successful or not. So that's an example of this of something that could be binomial. But the problem is it must satisfy all four. Okay? Third thing has so what is saying that the two outcomes are independent of each other. So if you write the first exam and you pass, writing the second exam is independent of the first. Okay? So each one of the finite number of times you write the exam has to be independent. That's okay with one? Yeah? So those are the first three things. Fourth thing is that the probability of a success or a failure between successive events P. Right? So it has, yes, it has a success or failure, but there's also something that you can calculate called the probability. So it has a probability of a success and a probability of failure. All right, between each outcome. Right? And you'll notice that we call probability of a success P and well, probability of a failure Q. Okay? I'm making you my idea how we can find Q. Very good. Q will be 1 minus P. Right? So I know you have these things, but just make a note of some of this. I want to write what Q was. No, everything in your notes. Right? Everything in your notes. All right. So let's say we satisfy now those four conditions. Then what we have is a binomial distribution. How do I write that? Well, there are two important things that every binomial should have. It should have a finite value n, and it should have p, probability of a success. So here's how you're going to write, right? Here's how you're going to write it. So a distribution x follows, that symbol means follows, a binomial, right? You could write b or you could write bin with the two parameters, n and p. Yes. Finally online. I'll just sign up. And then, I'll just send. Before. Right, sorry. So X follows a binomial, right? And these are the two parameters. N is the finite and P is the probability of a success, right? And Q is failure. Q is 1 minus P. Now, how do I go and find, how do I find the probability when X is equal to some random value R, right? So for example, it might have 5 trials. And I might want to know, okay, what's the probability of when X is 5, right? I'm going to have to use this nice little formula here. And I'll explain to you what this is. You're going to see NCR. I'll explain what this is. By P to the R by Q to the N minus R. Okay? This is NCR. I'll explain to you on your form, on a calculator. What is it? All right. So what's NCR? So sometimes here's what, right? Sometimes you might get something like this. Let's say you have let's say you have something like this. You have 10 trials, right? And you want to know what's the chances of getting 3 out of 10. Okay? It's a simple way to explain it, right? A little more complicated than this. But let's say you have 10 options and you want to get the probability of getting 3 or something, right? If you have 10 people and you have 4 boys and 6 girls, what's the probability of getting 3 boys? What you just use sometimes is something called 10C3. So you're using a function NCR in the calculator, somewhere close to the equal sign. Or by 5 or something like that. Some calculators an equal sign and some is close to the number 5 or something around there. So here what you just do. How do you find 10C3? What you just do is you put 10, then go to your calculator, press NCR and then press 3. And you'll get a particular value. How much is that? 120. So whenever you see NCR in a calculator, this is the function you're using. Right? So it gives you a little idea, okay, out of these 10, how much times I could get 3. Because remember, if I have 10, right, I could choose 10 things 10 ways, and I could pair them up, and I could triple them up, then I could 4, and so on and so on. So sometimes you want to know what's the option for getting 3 of those things out of 10. The order don't really matter, right? Later on, you will learn something called NPR, where the order you choose them in matter. I would do it without. Right? So all I want you to learn is how to find 10C3. 10C3, 10, go to your calculator, NCR3, and you'll get out. Okay? So let's just do a quick little thing here. Let's make up some numbers, right? So again, you'll recognize that n is small, right? N is small. If n get too big, it's no longer a binomial, it's no longer discrete. N is still small. So you might see something like this. When it's small, you will see spacing. But suppose n is 10,000 values, then this might happen. So close again. So technically, they might consider to be continuous. So when your distribution gets too big, it moves from discrete to continuous. All right? So let's try a small example here. Let's say I gave you a binomial. X follows a binomial. Let's pick a small value. Let's pick a value like 5, and P is probability, so that's 0.2. Let's see if we could find the probability that X is equal to 3. All right? To find this, I'm going to use the binomial distribution. N is 5, so that's 5C3, right? P is 0.2. And remember, if P is 0.2, Q is 1 minus 0.2, which is 0.8. So it's 0.2 to the power of R by 0.8 to the power of 5 minus 3. Go in the calculator and work this out. Remember, it's a probability, so it should be less than 1. Between 0 and 1. Wait, in the calculator, what you get? What you get? 0.0, 5 point 0. 0.0. Okay, nice. So that is to give you an idea how to work with it, right? But these questions now, what is making them tricky, there's common words, right? So there's common words, you have to figure out what they're asking for. Before we do that, remember, in any distribution, I should be able to find an expected value, E of X, right? And if I could find E of X, then I could also find variance of X, right? Those two values give you an idea how the values spread out, right? This one's an average, this one's a spread, okay? So how do we find the expectation? Really easy. If it's a binomial, they multiply n by p, right? You're getting it right there. For variance, NP. Of course, I'll write it here. I will get standard deviation. Square root of NP. Okay? So those are the three things that you need to know. What we're going to try now one time. We're going to try now to apply. We're going to try to apply what we just learned to a question. coming. Keep plus one coming. I'm gonna get one from here. One second. Plus one coming up, but don't go up to the now. All right, try that in. Right. Why is the one that there? Why is it a binomial? I know that we only doing binomial, but why do you think it's a binomial? Okay, let me go and make it. Mikhail, what do you think, right? Why it is that sorry. Did your fingers do the rest, right? The rest now? I do that. See the Saturday. Alright, now that's the best I can do. Tell me what you think. Why is that going to be a binomial? We know it's a binomial, but why? Take a minute, right? Look at the four rules. So. Yeah, I'll message you. Yeah, so Mikhail, what do you think, right? Why it is that satisfies being a binomial? Right? Because it has two probable outcomes. Either the pay with a credit card or they don't. What else? It's infinite and finite. Right? Infinite and it has a success or failure. So it satisfies all four rules. Okay? Are you okay with that? So good. So let's try this. So in doing a question, the first thing that we need to know is the parameters. X follows up, binomial, N and P. What are the parameters here? N is 10 and P is what? 0.6, right? Don't make the mistake and write 60, yeah? Unless you write 60%. Okay? Nice. Find the probability that exactly 2 pairs of credit cards. So they want you to find the probability that X is equal to 2. That's okay? But Joseph, help me with the next one now. More than, find the probability that what? More than X is more than 7. Not more than or equal to, more than 7, right? So how are you working out more than? Sorry. How are you going to work out more than? Because the formula I gave you there only works to equal to. What does more than 7 imply? Add 8 and 10. So more than 7 means you have to find the probability for 8, you have to find the probability for 9, and you have to find the probability for 10. Okay? Sometimes it's shorter to work backwards, when in this case, no. You want to find 0, 1, 2, 3, 4, 5, 6, 7. Sometimes it's easier to find the reverse and then do 1 minus. Okay? Yeah? So do my favor, work out X is 2, and then part 2. Right? Give my answer to 2 significant forms, right? Right, guys, a little weird trying to stick the 2 significant figures, right? Right, you finish the first one divides with 0.011. Altogether, right? Just to make sure you're doing it right. Right, that'll be 10C2 by 0.6 to the power 2 by 0.4 to the power 8. I got 0.011. Got the next one, tell me what you got. How much you got? Yeah. Oh, let's put it into. Alright, zip. Accurate. 0.17. Nice. So sometimes you have to figure out which part to take, right? If to find less than and then minus it from one, or just find the more than, right? You have to look out and see which one is less good. Okay. Any questions online? So for more than 7, the answer I have is 0.017. Okay? Are you okay online there? Kelly, are you okay there? Alright, let's go again. Right? And also, before switch, right? You have to remember what those words mean, right? What does more than mean? More than 7 means 8, 9, 10. Right? So you have to pay attention if you have to write more than or equal to. Okay? If I said at least 4, what you would write? Right? At least 4 means what? 4. So yeah, be more than or equal to 4. Okay, small things like that, right? All right. Let me jump in on the next one time. All right, so you might be able to, I'll show you all at once, right? So it's 22, so it's 2021. Forty. 2021 number 40. Right? You had it piece by piece, right? Didn't take it long, right? Alright, let's go. What distribution is that? Binomial. That's 3 marks, because there's no other distribution. There's no other distribution that's just created at this level. State parameters. Parameters are what? N is 20 and P is 0.25, right? Next. Find out. Determine the expected number of customers in this sample who do not, oh, by the way, while you're reading, right, it's important for you to identify what it's talking about, right? So you have to identify what P is. P is what? P is the probability that they do not make monthly payments. Because here they can come and ask you, what's the expected people who do make payments? Look out for the wording, right? Simple little words to mix it up. Right, anyway. Find the expected, what the formula is used here. Right, NP. Expected value N by P. So that's 20 by 0.25. I got 5. 5 customers do not make their monthly payments on time. Okay? Most important as you read, highlight those words, right? Highlight those important words. We can have the values, right? 20 and 0.25. Come here now. Right? We can't do part 6 again, right? But part 5. We do part 4. Oh, sorry. I left out part 4. Sorry. Check part 4. Yes. Okay. What? Point 0.20. Let's see. Any answers online? Any answers online? Nice. Right, so exactly 5. Probability of x is equal to 5, right? Probability of x is equal to 5. That will be 20 C5. 20 C5 by 0.25 to the power of 5. 0.75 to the power of 15. Now that was 0.2. 0. Okay, nice. Let's go again. Next part. Simple enough, right? The thing about unit 1 is that you don't really need to know. You know for sure once that is something discrete, you know for sure the binomial. Can't be anything else. Right, that's fine. At most 3. What's at most 3 again? 3, 2, 1, 0. Less than or equal to, right? This is 0 as well. Yeah. 0 as well, huh? 0, 1, 2, 3, right? And don't forget to include 0. Right? So I do 0, 1, 2, 3. What you got? You have the individual all together. All together. And we individually, like 0 and 1 and 2 and 3. Yeah? How much you got for 0? 0.00. How much you got for 1? 0.0 to 1. How much you got for 2? 0.067 and 3. Right. So your final value is what? 0.252. Yeah. What's the expected value again? What's the expected value? No, the expected value will go in part 2. The expected number of people, like 4. 5, it was 5. Okay. So just how the reason I wrote that down, right? Which one do you think would have the highest probability? X equal to what? I mean general. In this distribution, which of these do you expect to have the highest probability? So far, when X is 0, it's looking like that. When X is 1, it went a little bit higher. Huh? So, right, when X is this one a little bit higher. Next one much higher. Which one do you think will be the highest? X is 5, right? So 4 might be here, 5 might be here, then might start to come back down. That's okay? For those who did it already, if I increase the number of n, what would it look like? Here, look like the normal. And y'all did normal already, continuous. Let's say I put plenty values here. If I increase of n is 20 to like 100 or 200. See our shape? Like normal. Yeah. So watch this down here. You can't use that, but I didn't teach yours yet, right? So I wouldn't do it, right? Watch this here. A new director was appointed and decided that a larger random sample of 100 customers would give better results. Use a suitable approximation. So you'll see why binomial will no longer work. But we had to use a normal, right? Will you okay with that? So when the distribution gets too big, it no longer is binomial. It starts to get discrete. Right? I'll try to show you why I did. That's okay? But of course, I didn't show you that as well. Next one. All right, online, for those who never did it before, as the binomial gets large, we have to convert it into a continuous distribution polynomial, right? Which I'll show you next time. Next one. What year was that? That was 21, right? Let's take a look at going back the next one, right? And I said you mightn't believe it, but yours technically covered half syllabus level. Module 1 and number 3. Next one. For the cards levels. Oh, by the way, in applied maths, they expect you to know about cards, huh? So they expect you to know like have 4 suits. They expect you to know what's a face card. They expect you to know a few things about them, right? Ace is a first card. Is a face card? No, they don't have a face. Right? Only king, jack, and queen is a face card, right? All right. Remember those little things. How many suits it have? 4. How many cards each suit have? 13, right? 3 face cards and 10 others, right? Ace is not a face card, eh? Ace is like 1, right? Okay. So if you never play cards before, your homework is to go and play cards, right? Because they will expect you to know some things about cards. Right, so Priya and them sending some things, man. Nice. Go ahead. Give them 2 reasons and let's move on. This is 2019, right? It's in the group. So you can pull it up and do out the whole question. We are doing A, B, A and B. Right? We can't do C as yet. So in an experiment, the card is taken from an ordinary deck. It is noted whether or not it is a picture card, so they tell you what picture it is, and then the card is returned in pack. Okay? This process is repeated 12 times. X is the number of picture cards noted. So 3 reasons why. Number one, n finite. N is finite. N is, well, is there a success or failure? Yes. A success is obtaining a picture card, a failure is obtaining a non-picture card. Could a probability be calculated for getting a picture card? Yes. And of course, well, if you can calculate P, you can calculate a. Okay, so you have to give those 2 reasons, right? $19. Right, I'll give 2 reasons and then move on to the parameters and things. It's in the group, make it open it up, right? And draw the whole of 2019. A and B. 2019, it's in the group for A and B. The parameters are what? Right, cards people. Let me hear all the little cards. Let me hear what you all came up with. Let's see if playing cards helping out. N is how much? N is? Right, let me hear P. How many picture cards we have? How many picture cards we have? 12, right? 12 over 52. Did any cards in school? Are you really rattling all them numbers, boy? Yeah, 12 on 52, right? So the probability of picture card is what? 0.25, right? No? Well, sorry, it's 0.23. Oh, sorry. Oh, yeah, divide wrong, divide wrong. 13 will be out. Right, fine. Right, nice. Move on. Next part. Right, do everything except the last part, right? I just want to introduce the continuous random variable, right? Right time. Next part. Next part is the one, the expected value. Don't just jump into finding the expected value, right? Tell them the distribution first. X follows a binomial. N is 15 and 0.73. So 0.73 is the people who will do a put past that to drive test. Okay. So they wanted the expected values, write the formula N by P, and they good to go. How much is that? How much? Well, give me the exact value first. 10.95, so that's 11 people, right? 11 students. Right? Expected to pass. Again, when you read it, pay attention to the words. Right? They can always put it up and say expected to fail or something like that, right? Any questions online? Are you okay there? Sophie? Easy, right? Nathan? Nathan, you there? Keisha, okay? Keisha, in this class? Keisha, in this class? Yeah? Tell me the school or Keisha? No? Olha, just remind então, start your watch. Last part. Last part. Find the probability of exactly 12 will pass. I can't remember the year, but one of the years when they ask you will not pass. What you will do? What you will do if the question said the probability that exactly 12 will not pass? Switch PM key. Very good. Look out for that. Huh? Those are the little things that is switch on your right. Go ahead, check part 3 and we're done. You're done? Nice. So the probability of x is equal to 12, right, is 15C12 by 0.73. 0.73 to the power of 12, 0.27 to the power. That's okay? How much is that? 0.21? 2 ounces. Yeah? No? I'm killing it up. Do they figure it out? 19. What do you got? What do you got? 21? All right. So that's binomial. All that could come hard in binomial is they could ask you for the four reasons why it's a binomial. Yeah, justify it, and then they can switch up the wording on it. So nothing much harder than that. Right? What has come tricky in this is now when the distribution gets bigger than 15, right? And it becomes a normal. Okay? All right. I just want to do one little thing today before we wrap up because we're missing next week where I want to do the normal. On the group, I'll pull to see what day possible, right? Right? Tuesday possible for me, Thursday possible for me, Sunday possible, early Monday, on the holiday. Right? All right. Well, we'll see which one will work out. All right. Before we wrap up, I know, but I would like to do things too far. Consider that important. So we'll see. I'm going too far, but then if you go, especially with this. All right. So that's one little thing I want to talk about. Everything that we did so far had to do with discrete random variables, right? As I said, there's only one discrete distribution in unit 1. Okay? In unit 2, so for you, right? A continuous random variable, then there's a quick little thing there, it's in your notes already. A continuous random variables are variables that can possibly have right more outcomes between the discrete values and must be integrated into the group, right? So why it have integration, right? So it don't really have integration because integration is the way to get it for any function. But in unit 1, here what does it do? Look at the one underneath. See this here? It's a nice straight line. So if I said, okay, find the probability between 2 and 4, what you have to find for me is this area here, right? You have to find that area there. Are you okay with that? But you know why to integrate. If you can integrate, that's good, but you know why to integrate. What you can do here, Joseph, is just simply find the area of the shape there. That's okay? So the area of the shape represents the probability. Everybody okay with that? Yeah? But it's also important to know how to integrate that. Right? The earlier years, when you're practicing them, they might be trained. Right? But everything after 20, 14 or 15, somewhere around there. 13 is just to find the area using trapezium or triangle or rectangle. Okay, so that shaded region there represents the probability for the distribution. You okay with that? So you have to actually find the area. Okay. So we need to learn that, right? Though all that wouldn't just simply saying that the area under the graph represents the probability. Okay, so in a continuous distribution, that area is the probability. Now, we can't find expectation on thing because in unit 1, unit 2, you can do it. Expectation is the integral between x by the function. So you have to multiply everything by x. And then e of x squared is the integral of x squared. Right? So you'll do that twice in unit 2, and then you can find the variance. Okay? And then what we're going to focus on, so we'll do a couple of examples on that. What we're going to focus on is this special distribution here called the normal distribution. You'll see how it's shaped? It's a bell shape, where the highest point is the mean. Right? Like the example I was trying to show you all. The highest point or the highest probability caters to the mean. Okay? So we are going to learn how to get the values over this. And because there are so many values, what they allow us to do is to take a table and read the value. But here's my homework for you. My homework for you is to learn to use a calculator to get the normal value. Your calculator has the normal distribution on it. I want you to learn to use it. Okay? So on a calculator has the normal distribution. So if you plug in your mean and your variance, you could read it home. Okay, so I want to learn to do it. All right, so next day we are going to focus on a couple of continuous distribution values, more so the normal distribution. Okay, that's where the hard part in module 2 is. Not really hard. That's the only tricky thing in module 2. All right, so that's it.